Okay, so let's now have our practice problem number 1. For the truss, design the end diagonals and top chord members, group D, E, F, and G, using W12 sections, A36, tail, and LRFT. Assume K is equal to 0.9 and all joints are adequately laterally supported and PU is equal to 270 kilonewton. So as you can see, this is the same truss from our practice problem in tension members. But we have solved the bottom chord, groups A, B, and C. But for this particular problem, we will be solving groups D, E, F, and G. So this is your D, E, F, and G. Alright? So as you can see, these are compression members. Okay? So I will not discuss how to compute for the internal forces of these members, but I will just include, or I will just write the maximum forces for all of the groups. Okay? So for FD, we have 5 over 4 times 675. Remember, our R that we have computed last time is equal to 675 kilonewton, right? So we have FD is equal to 5 over 4 times 675. You have 843.75 kilonewton. Now for FE, you have 6 over 4 times 675 equal to 1012.5 kilonewton. For FE, for FF, you have 12 over 4 times 675 equal to 25 kilonewton. And lastly, for FG, you have 18 over 4 675 equal to 3037.5 kilonewton. Okay. So we now have our values for all the internal forces of the groups, of the member groups. Okay. So we can now compute for, or we can now design our members, right? So as I mentioned, the design process always requires iterations or ulit-ulit ng pagsosolve. But I will just show you the final iteration na pwede nang acceptable. Final iteration with acceptable result. Okay? Now, let's have the computation for group D. Okay? So for group D, your L is equal to 5 meters. Okay? So let's try W12 by 40. So your W12 by 40, we have A is equal to 7,550 millimeter squared, and your RY is equal to, or your radius of gyration about y-axis excuse me, is equal to 49.3 millimeter. So we can now compute for the slenderness ratio. The slenderness ratio is equal to KL over R. your KL over R is, remember, we are to assume that K is equal to 0.9. So 0.9 times 5,000 over 49.3. So you have here 91.278. Okay. So now we can now compute for the buckling stress, or your FE. So FE again is pi squared times E over KL over R squared. So we have pi squared equal to 200,000 because we're using a 36, and your KL over R, which is equal to 91.278 squared. So that should be equal to 36.92 MPa. But still, we should be comparing this to the value of 0.44 Fy. So you have 0.44 248, which is equal to 109.12 MPa. So this means that your Fe is greater than 0.44 Fy. Ano ibig sabihin nito? So, ibig sabihin nito, your FCR, therefore, your FCR is equal to 0.658 raised to Fy over Fe times Fy, so that is equal to 0.658 raised to 248 over 236.92 times 248. So that should be equal to 160.02 MPa. Okay, so after that we can now compute for the actual capacity. Which is your P cap. So your P cap, again we are asked to compute using LRFT, so we'll be using pi C times A times FCR. So you have here 0.9 times 7,550 times 160.02 over 1,000. So you have 1,087.3 kilonewton. So after that, we have to compute for the demand over capacity ratio, or your DC ratio. Ano ba yung demand natin? So according to our maximum forces, your FT is 843. So you have here 843.75 over 1,087, which is the capacity of your, or your actual capacity of your W 12 by 40. So computing this, you have 0.776. Okay, what does this mean? Okay, ano ibig sabihin ng 0.776 natin? So, ibig sabihin yan, 77.6% lang ng capacity ng W12 by 40 yung nagamit para dun sa group D na N diagonal. Okay? So kung para dun sa N diagonal natin, ang ginamit natin is 12 by 40, ibig sabihin nun, 77.6% lang na capacity yung specific wide flange section na yun ang nagamit. Okay? So ang masasabi natin na pasado. Okay? Pasado yung member natin. Pero hindi sagad na sagad sa capacity. Okay? So, kumbaga, may allowance pa siya na 22, if I'm not mistaken, 22% na allowance, di ba? So, ganun yun. Yun yung usually na tinitignan pag nag-optimize ng design sa yun, pag nasa industry na kayo and you're optimizing your designs. So, ito yung mga isa sa mga or pinaka-tinitingnan talaga yung demand over capacity ratio. Ibig sabihin kung pasado na ba. Okay? So, ibig sabihin yan kung ang demand capacity mo or your demand capacity ratio is already 1 na, lumabas dito is 1 or equal na yung demand and capacity mo. Ibig sabihin nun, 100% ng capacity na nung section mo ang nagamit sa particular member na yun. Okay? So, kumbaga, sagad na sagad. Okay. Ganun yun. Alright? So, we now have our section for group D. So, we can now proceed for your group E. Now, for group E, your L is equal to 4 meters. So, let's try again W12 by 40. So, again, your W12 by 40 is equal to your A for your 12 by 40 again is 7,550 square millimeter, and your RY is equal to 49.3 millimeter. So let's compute for the KL over R. KL over R is 0.9 times 4,000 over 49.3. So we have here 73.022. So after we get our KL over R, we can now compute for the FE. So FE is equal to pi squared E over KL over R squared. So that's equal to pi squared times 200,000 over 73.022 squared. So that is equal to 370.18 MPa. And again, let's look for the value of 0.44 Fy, which is 109.12. So this means that your Fe is greater than 0.44 Fy or 109.12. So because of that, your FCR will be equal to 23.658 to the power of 248 over 600. Oh, sorry. Raised to 248 over 370.88 quantity 248. So that should be equal to 187.36 MPa, right? So for the P cap, or the actual capacity, so that is pi sub c, or sorry, phi sub c times A times FCR. So you have 0.9 times 7,550 times 187.36. So that is equal, sorry, still have the conversion for us to have the kilonewton result. So we have 1,273.1 kilonewton. So for your DC ratio is 1,012.5 over 1,273.1. So your DC is equal to 0.795 or 79.5% ng capacity ng W12/40 yung nagamit sa group E. Alright? So meron na tayong design for group D and group E. Meron pa tayong dalawa. Okay? So for your group F, excuse me, your L is equal to 4. So let's try W12/58. So for your W12/58, your A is equal to 11,000 square millimeter, and your RY is 63.8 millimeter. So computing for your KL over R, slenderness ratio, you have 0.9 times 4,000 over 63.8. So we have here 56.426. Now for your FE is equal to pi squared E over KL over R squared. So pi squared times 200,000 over 56.426. So you have value for FE equal to 619.96 MPa. And comparing this is greater than 109.12 MPa. So therefore, your FCR is equal to 0.658 raised to 248 over 690.96, quantity 248. So that is equal to 209.77 MPa. So let's now compute for the P cap actual capacity. We have Phi sub C A FCR. So you have 0.9 times 11,000 times 209 over 1,000. 76.7 kilonewton. So your DC, meron na tayong value for your pickup, which is 2076.7 kilonewton. So let's compute for DC ratio. Now your DC ratio is equal to 2025 over 2076.7. So computing this, you have the DC ratio equal to 0.975. Right? And lastly, for group G, okay, last group. So for group G, your L is also equal to 4. So let's try W12 by 87. So for W12 by 87, you have your area equal to 16,500 square millimeter, and your RY is equal to 78 millimeter. Okay. So your KL over R is equal to 0.9 times 4,000 over 78. So that is equal to 46.154. Your FE is equal to pi squared times E over KL over R squared. So pi squared equal to 200,000 over 46.154 squared. That should be equal to 926.65 MPa. Comparing this is greater than 109.12, or our value for 0.44 times Fy. Now, so therefore, your FCR is equal to 0.658 raised to 248 over 926.65 quantity times 248. Your FCR is equal to 221.72 MPa. Now for your actual capacity, your actual capacity is equal to pi C again, or sorry, phi C times A to the power FCR, times A times FCR, sorry. So that, I'll just be clear. Phi sub C equal to A times FCR. Yeah. So that is equal to 0.9 times 16,500 times 221.72 over 1,000. So that is equal to 3,292.5 kilonewton. So lastly, we can now compute for the DC. DC ratio. our DC ratio, demand capacity ratio, is equal to 37.5 over 3,292.5. So that is equal to 0.923. Okay? So let's summarize. For group D, we use W12 by 40 and your TC ratio is 0.776. For group E, we use W12 by 40 also, and our TC for that is 0.795. For group F, we use W12 by 58, and we have our DC equal to 0.975. Then lastly, for group G, we use W12 by 87, and DC for that is 0.923. Alright? So, meron na tayong design for groups D, E, F, and G. Okay? So, kung mapapansin nyo, the first group is more 75% ng capacity yung nagamit. And for group F and G, almost agad. Diba? Nasa 97 and 92%. Okay, so ganun lang lagi sa design. So, you always look for the D over C or the design capacity ratio para malaman nyo kung nami-meet ba nung section nyo yung force na kailangan o nami-meet ba nung section nyo yung kailangan niyang capacity. Okay, based dun sa actual or demand force. Okay, so mapapansin nyo ang ginamit natin is RY, di ba? Lagi natin ginagamit RY. Bakit nga ba diniretso na natin to RY? Okay? Because if you look at the table, or if you're first selecting the section that you will try for your different iteration. So, kung titingnan nyo kasi yung RX and RY ng yung RX and RY kung compare nyo RX and RY nung W flange nyo, yung RY kasi yung magbibigay ng critical ratio. Okay? Yun yung most likely magbibigay ng critical slenderness ratio natin. So, yung RY yung pinili natin. Okay? So, let's still have some practice problem. Alright?